In this section, we're going to develop a library of functions that we're going to be using throughout the rest of the semester, and these will pop back up when you take calculus. It's just good to have an idea of all of this information for each type of function, and then we're going to build more and more functions as the semester goes. So for the first one, the identity function y equals x, when you plug in your x, you get the same thing back for your y. So you get 0, 0, 1, 1, 2, 2, negative 1, negative 1, negative 2, negative 2. So you end up getting just a line through the origin with slope 1. The domain of this, there's no restrictions. We're not dividing, we're not taking square roots. So the domain is all real numbers. The range, well, it's also all real numbers. The x-intercept is at 0, the y-intercept is at 0. The symmetry, well, it's not even because it's not symmetric over the y-axis. If we took this graph right here, spun it 180 degrees right about this point, you'd get the exact same graph back. So that means that this is an odd function. Where it's decreasing is nowhere. And to represent that, that's the empty set. And where it's increasing is everywhere, so on the entire domain. We have no local max, no local mins, no absolute max, and no absolute mins. So we can do like NA for each one of these for not applicable. Neat. The next one is the square function, where you take a number and you square it. If you take 0 and square it, you get 0. You take 1 squared, you get 1. Take 2 squared, you get 4. And we saw this in the previous sections where this is an even function. So once we know what's happening to the to the right of 0, we get what's happening to the left of 0 for free. Notice that, again, no division, no square roots, so the domain is everything. The range, if we collapsed this whole picture down onto the y-axis, the range is just looking for what gets covered up. So 0 is covered up, and everything above 0 is also covered up, but nothing below 0 gets covered from this graph. So the range is 0 to infinity, including 0. Our x-intercept and our y-intercept are both 0. The symmetry we know is even. It's decreasing when your x value is negative. So as you move from left to right, this thing is coming down. So that's going to be negative infinity to 0. And then it's increasing from 0 out to infinity. We don't have any local maximas. A local minimum, we have one of those at 0, 0. Since we have no local maxima, we have absolutely no absolute maxima. And since we have, this is the lowest possible point, we get that the absolute minima is 0. The next function is the cube function, or cubic. And just like the square function, you take a value, but now we cube it. So if you have 0, you get 0. When you cube 1, you get 1. When you cube 2, you get 8, so that's somewhere up here. We know what this should look like. We know it's an odd function. So it looks somewhat like that. Again, we can get the domain is all real numbers. The range is also all real numbers. The x-intercept is 0, the y-intercept is 0. It's decreasing nowhere. It is increasing everywhere. There is no local max, right? Because if you pick out any point, right to the right of that point is going to be something that's a little bit higher up. And also there's no local minima, no absolute. There we go. Then the next one we have is the square root function. So we're going to take square root of 0, which gives us 0, square root of 1, which gives us 1. And then the next nice square is going to be when we take the square root of 4, and that'll give us 2. that thing just keeps going as such. So notice that the domain of this thing is 0 to infinity. The range is also 0 to infinity. The x-intercept is 0, y-intercept is 0. Symmetry, none. Right, because that's not a symmetric domain. Where is it decreasing? Nowhere. Where is it increasing? All over its domain. So from 0 to infinity. Local maxima does not have one, which means there's no absolute. Local minima, we have one at 0, which means that's the absolute. So that's the lowest possible value right over here. Notice that there's somewhat of a relationship between the way this function has, this graph and this graph look. And we'll talk about that more when we get into exponentials and logarithms.